Everybody loves candy. Everybody. Kids, moms, dads, doctors, demolition derby drivers, everybody. Heck, you show me an American that doesn't have at least one or two sweet teeth in his head, and I'll show you somebody that's, well, just shy of trustworthy, if you know what I mean. Oh, here, watch. City Councilman, have us a little bit of fudge.
No, thanks. Never touch the stuff. Here, have a button.
Thanks. See what I mean? And this is fudge we're talking about. You know, I can't think of a candy that is more American, yet most Americans would rather shell out $5 for a wedge of someone else's heaven than walk into a kitchen and make their own. And that's a real shame, because if you've got a pot, a thermometer, some basic ingredients, and just a little science in your soul, you too can produce fudge that is really, really You know, fudge isn't defined so much by flavor as it is texture. And that texture is defined by crystals. Little itsy-beatsy sugar crystals, in fact, that are completely surrounded by a very concentrated sugar syrup. So it follows that if we are going to make fudge, we're going to have to make some crystals. Of course, before we make crystals, it'd really help to know exactly what crystals are. Is there a crystallographer in the house?
Yeah, I'm a crystallographer.
You mean that's a real word?
Yeah.
Outstanding. What does a crystallographer do?
Well, we grow crystals and we study the structure of the atoms or ions that make up a crystal.
Perfect. And you can probably answer my question. What is a crystal?
A crystal is a solid that has a regular array of ions, molecules, or atoms.
Are all crystals alike?
No, this is a crystal of sodium chloride.
Salt?
Salt, yeah.
You're right. So this is like evaporated, right? This probably came out of a pond someplace or a lake.
Right.
So there's a different kind of crystal? They're not all like this?
Yeah.
Because I could make this myself if I had a really big pot.
Well, these are crystals of quartz that have been grown from pure silica over thousands of years.
Okay.
Much different.
So sugar is probably more like this one than this one.
Yes.
Sugar's like this, diamonds like that. Great. I'm betting you've got a laboratory, don't you?
Oh, yeah.
You probably got some pretty big microscopes, X15-Ps, that kind of thing. Yeah,
yeah, we call them diffractometers.
Diffractometers, perfect, just what I was hoping for. Do you think you could take my fudge back to your lab and maybe take a look at it with one of your gizmos?
Sure.
Great. I tell you what, you take this, I'll hold your crystal for you, and I'll just wait for you here, okay?
Okay.
Hurry on back, have fun with that.
Okay, I've proved that your fudge has crystals in it.
Oh, look at that. Here. What do you got?
Okay, here are just sugar crystals, commercial sugar.
Okay, kind of cubey. And
Now this is an expanded version under a microscope of your pieces of fudge. You've got individual crystals. Now we can prove that they're crystalline by shooting X-rays at it. According to Bragg's law, you get these individual spots of the diffracted X-ray beam. Now when you shoot the X-rays at fudge, you get many, many spots, and that indicates that this is a powder pattern, and we can prove that that's the same sugar as what you started with.
Great, so my crystals are in the fudge. Great. Did you bring the fudge samples back to me?
No, it tasted too good.
Of course. Now that we're crystal clear on crystals, let's make a few million, shall we? Of course, we're going to need some hardware. For instance, a heavy-duty 2-quart saucepan and a wooden spoon. More on why wood later. Software will include 2 cups of sugar and 2 cups of H2O. The third ingredient is, of course, heat itself. Turn this to medium-high and bring to a boil. This would be a good time to talk thermometers. The diagnostic mercury bulb thermometer was invented in 1866 by a British physician named Sir Thomas Allbutt. Ironic, don't you think? The device is simple enough. The liquid in this reservoir expands when heated, pushing upward into a narrow tube calibrated to the corresponding temperature. Dr. Allbutt chose mercury because it's one of the only liquids that doesn't stick to glass. It doesn't boil till it hits about 674 degrees, and being metal, it conducts heat very quickly. Now, make a few adjustments and you've got yourself a darned accurate and economical kitchen thermometer. There are some downsides, however. These things are a beast to read, and if you happen to break one, well, you might be in trouble because mercury, and especially mercury fumes, are extremely toxic. Some bulb thermometers get around mercury by using a dyed alcohol, either in blue or red. But such devices are not as accurate as mercury. They're darned hard to read and still prone to breakage. Now, despite the fact that they are a snap to read, bimetal or bonded coil thermometers do not cut it in Candyland because they are sluggish, notoriously inaccurate, and require frequent mechanical recalibration, which is not nearly as much fun as it sounds. Luckily, temperature changes the way electrical currents move through certain types of metal, and that makes reliable and accurate digital thermometers possible. My favorite candy thermometer, which also doubles as a fry thermometer, has a snazzy on and off switch so that I don't waste my battery. It's got a nice long probe, a stout heavy-duty clip, a very, very easy to read digital face that even has a little steam shield. Sweet. As you can see, all of our original sugar crystals have dissolved, creating a sugar solution, or syrup. Now, on a molecular level, this is kind of like well, it's kind of like a slow dance. I know, I've used the dance metaphor before, but hey, if the tap shoe fits. Now, let's say that these couples are sugar molecules. The guys are the glucose side of the disaccharide, and the gals are the fructose side. Now, at this point, the solution's not too hot, so they're moving around, but not too fast. And at this point, the molecules are more attracted to the surrounding water than they are each other. So crystallization is out of the question. That, however, is all going to change when this comes to a boil. Clamp on the lid for 2 to 3 minutes. The trapped steam will condense on the lid, roll down the sides, and dissolve any errant sugar crystals that might be lurking there, waiting to set off a chain reaction of crystallization. That is something we're just not ready for yet. We are, however, ready for a thermometer. As the solution boils, it becomes more concentrated because the water can escape as steam, but the sugar can't. As a result, the temperature of the solution begins to rise beyond 212 degrees Fahrenheit. So, not only are the sugar molecules moving around a lot faster now, they don't have near as much room to move in. In other words, this solution is concentrating. Now, by watching the temperature, you can gauge when the concentration is right for forming the crystals and therefore the candy of your choice. In our case, that is, of course, fudge. How did early confectioners judge the concentrations of their syrups without thermometers? Well, it just so happens when a small dollop of syrup is dropped into cold water, it behaves in a very specific way, depending on the sugar concentration. From 230 to 234, it forms soft threads. Between 234 and 240, it forms a soft ball, meaning that it's just right for fudge or praline making. Between 244 to 250, you get a firm ball. Now's the time to make caramels. From 250 to 266, you get a hard ball. Exit now for Definity or Nougat. Taffy makers wait for 270 to 290 when hard but pliable threads form in the water. Threads also form between 300 and 310, but they are very, very brittle indeed. In fact, this is called the hard crack stage, and it's perfect for hard candies like brittles and lollipops. Our syrup has just crossed over to 232 degrees. Now, traditionally, fudge is made closer to 236 degrees, but it will definitely carry over, so I'm just going to turn off the heat and let it coast to its final thermal destination. And at this point, you want to avoid any and all agitation. Why? At this point, the solution is saturated. That means that at this point, there is so little water left in the matrix here that the individual sugar molecules are as attracted to each other as they are to the surrounding water. Okay, this is kind of a dangerous time because if you were to say, drop in an undissolved crystal from your stirring spoon, or if a piece of big dust happened by, or if you just gave the mixture a little shake, the molecules would start to collide together and form into what is called a seed crystal. And seed crystals can result in very grainy messes. Kind of looks fun, though. Well, look at what you've done now. Only way to repair this mess is to add a bunch more water and redissolve all the crystals. what a mess. What say we start over, and this time let's invite some flavor to the party as well as a few crystal control agents. Ugh. Yuck.
This time we kick things off with 2 3/4 cups of sugar, 4 ounces of unsweetened chocolate, 2 tablespoons unsalted butter, 1 tablespoon of light corn syrup, and 1 cup of half and half.
Why the corn syrup? Because it is composed of glucose, which is a kind of sugar, but it is not the same kind of sugar as sucrose, which is what the white table sugar is made of. So it can't take part in any of the white sugar's crystallization games. As for the chocolate and the butter and the cream, sure, they're going to bring a lot of flavor to the fudge, but they will also affect the final texture. Now, when this new and, improved solution gets hot and bothered, all these alien molecules are going to get in between the sucrose and prevent them from committing premature crystallization. And that, for fudge at least, is a good thing. Stir this mixture over medium heat until the chocolate and all the sugar is dissolved. When you are sure that all the sugar is dissolved, increase the heat and bring to a boil.
Time to contemplate the fudge's final resting place. You're going to need an 8 by 8 inch glass baking dish, a piece of parchment paper that's at least 2 inches bigger all the way around, and some unsalted butter. Liberally lube the dish and your spatula, and then take a paring knife and slit the corners of the parchment paper thusly. That way, you'll be able to put the parchment directly into the pan and overlap the sides for a snug fit. Neat trick, huh?
When the mixture reaches a full boil, reduce the heat to medium-low and slap on a lid for 3 minutes. Why bother? Again, this is the point in time when crystallization could occur on the side of the vessel. We don't want that. The lid will cause condensation. Condensation will keep the walls clean. 3 minutes. Go ahead and attach your candy thermometer. If your thermometer happens to have an alarm on it, set it for the softball stage, or if you can pick a temperature, say 234 degrees, unless, of course, it's raining. Behold, kind of gooey. Wasn't like that yesterday. Of course, the sponge wasn't dry yesterday. See, the problem is sugar is hygroscopic. It can and will suck water right out of the air. In this case, enough was quaffed to actually dissolve some of the crystals I worked so hard to make. The rule, if you have to make fudge in high humidity, you should compensate by cooking your syrup a few degrees higher than what the recipe calls for. Sure, the texture may seem a little on the grainy side at first, but it'll soften up in a day or two. As soon as the mixture hits 234, turn off the heat. Just turn it off and leave the pot alone. Sure, it's going to continue to get a little hotter, but then it's going to start cooling down. And we want it to cool down to 110 degrees. Why? Why?
Well, if you shake it or stir it or do anything while it's really hot, a few crystals will form and they'll grow and grow and grow, and your fudge will be grainy. But if you just let it sit perfectly still, as it cools, it gets thicker and thicker and thicker. And then your little sucrose molecules, they can't bounce all over the place. They have to stay right in the neighborhood. So they're going to make little baby crystals. So if you just let it sit perfectly still and stir like crazy, you'll get thousands of baby crystals at once.
Okay, so if I stir now, I get really big crystals. If I stir it when it's cool, stir like crazy, I get little bitty crystals.
That's right.
Got it.
You better put some butter on right now. It'll
What?
keep it from drying off on the surface.
Well, we have attained 110 degrees. Now it is time to make the crystals. Ooh, nice idea, but no. A mixer would work too much air into the fudge and that would ruin the texture. This, I'm afraid, is a job for a good old-fashioned wooden spoon. Wow, this is kind of hard to do and talk at the same time. Shirley, could you take over for me here?
Sure. Now, the faster you beat, the finer the crystals are going to be. And now watch it, because when that shine goes to a sort of a matte finish, that means it's getting close. You can slow down. But now you want to test it, do a blob, and if it falls in a clump, it's thick enough, and it's time to put it in a pan. Here's the time to add vanilla, too. And if you want to add nuts, now's the time. Alton, roasted nuts. I have to keep an eye on him all the time.
The one thing Shirley didn't mention is that once the nuts are in, the mixture is going to cool down very, very quickly and start to set up. So get it in the pan fast. And no, if it sets up in the pan, you can't just heat it up again to loosen it. You'll have to eat it out of the pot. There we go. I'll just smooth it with a silicone spatula. Don't try doing this with the wooden spoon. It'll be a mess. There we go. Now, let this cool down for 2 hours before you attempt to cut and consume. And whatever you do, don't put it in there. It's too wet in there for this kind of fudge. If you've ever made one of the many fudge recipes featured on packages of baker's chocolate or cans of condensed milk, odds are good you've employed the microwave. Now, how can you possibly make decent fudge in a microwave? You can't, but you can make a darn nice fudge-like candy. And what's even better is that since it steers clear of the cooktop, kids, you can make it all by yourselves, if mom and dad say it's okay. Now, the software. Start by cutting up 2 sticks of butter, unsalted, and add to that a cup of peanut butter. This is a microwave-safe bowl, of course. There we go, smooth peanut butter. I'm gonna cover this with plastic wrap, poke a couple of holes for steam, and microwave on high for 2 minutes. Now I know there's a good bit of fat in there, more than you would ever have in a stovetop recipe, but since we're not going to be producing a syrup, we still need a viscous liquid for those crystals to suspend in. In this case, it's going to be fat. It is going to taste real good though.
When last we spoke, we had combined 1 cup of smooth peanut butter with 1 cup of unsalted butter, covered it, and microwaved it on high for 2 minutes. Now, carefully remove the plastic wrap, just enough to get your spoon in there. Of course, if you poked holes in the top of the plastic, there shouldn't be much steam. Give it a good stir to thoroughly combine those 2 ingredients. Then recover it with the plastic and slide it carefully right back into the microwave for another 2 minutes of cooking on high.
Now, remember, this will be hot, kids, so properly protect your digits. Now, we add the rest of the ingredients after carefully removing the plastic. There's still going to be some steam. There we go. First, we have 1 teaspoon of vanilla extract and 16 ounces of instant seed crystals, otherwise known as powdered sugar. Now keep stirring until this mixture loses its luster and takes on a decidedly dull appearance. After a while, it's going to get really hard to stir, and forget that. There. Now, you're going to need a baking dish prepared exactly as for our chocolate fudge earlier on. Just kind of scoop this in. Sometimes I like to smooth the top with a metal spatula. You don't have to. There. Now, this needs to be stored in the refrigerator because it's got a looser consistency. You know, it won't stay solid any other way. But before you insert this, take out a little insurance policy against refrigerator funk. Just a piece of wax paper right on top and fold over those edges. There. Well, I hope we've given you the confidence and the drive to become your very own Candyman. Fudge is just the beginning, of course. Once you get used to working with thermometers and syrups and such, lollipops, toffee, pralines, even better cake frosting are right around the corner. The corner on a block, on a street, in a town that we call Good Eats. Thanks. Time.